In this video, we are going to do the MCQ questions of NCERT textbook of matrices and determinants. Question number 15. A is Aij, whose order is m by n, is a square matrix if we know that for a square matrix, number of rows and columns should be equal. So C is the correct option. M must be equal to n. Question 16. Which of the given values of x and y make the following pair of matrices equal? When two matrices are equal, we know that the corresponding elements should be equated. So 3x plus 7 equal to 0, y minus 2 equal to 5, y plus 1 equal to 8, and 2 minus 3x equal to 4. Let us solve for x. We get minus 7 over 3 from the first equation, and from the fourth equation, we get x as minus 2 over 3. We don't get the same answers for x, therefore the answer is not possible to find. Whereas here y values are same. By solving two different equations, if we get two different answers for x or y, we should say that not defined or not possible to find. So the correct option is B. Question 17. The number of all possible matrices of order 3 by 3 with each entry 0 or 1 is. The matrix is of order 3 by 3. We will have 9 elements. A11, A12, A13, first row elements. Second row, the third row. Now for each element, we have two options to write. We can enter either 0 or 1. So two ways are there to fill up this position. Similarly, we can write either 0 or 1. So two ways for this, two ways for this. So for each entry, we have two possibilities. Therefore, the total number of possible cases will be 2 into 2 into 2, 9 times, which is 2 raised to 9. The answer is 512. D is the correct option. Next question. Assume X, Y, Z, W, and P are matrices of order. X is of order 2 by n. Y is of order 3 by k. Z is of order 2 by p. W is of order n by 3. And P is of order p by k, respectively. Choose the correct answer in exercises 18 and 19. The restriction on n, k, and p so that py plus wy will be defined are: p is of order p by k, y is of order 3 by k, w is of order n by 3, y is of order 3 by k. This product py is possible only when k is equal to 3. That is, number of columns of the first matrix should be equal to number of rows of the second. Here already they are equal. So we have a condition that k must be equal to 3. Now let us see the order of this product. The order of this product will be p by k, the first and the last numbers, plus order of the product wy will be n by k. Now we have to add these two matrices. For addition, we know that the orders must be same. By equating the number of rows, we get p is equal to n. Number of columns, already they are equal k. Therefore, we have two conditions. K is 3 and P is n. The correct option is A. Question 19. If n is equal to P, then the order of the matrix 7x minus 5z is. 7x is of order 2 by n. 7 is a constant. Minus 5z is of order 2 by P. We are subtracting these two matrices. Orders must be same. Already their rows are same. Number of columns also should be same. N must be equal to P. Therefore, order of these matrices should be either 2 by n or 2 by p. Here the given option is 2 by n. Therefore, B option is the correct answer. Question 20. If A, B are symmetric matrices of same order, then AB minus BA is we have to check whether it is skew symmetric, symmetric, zero, or identity matrix. A and B are symmetric matrices. We know the definition of a symmetric matrix. A dash is A and B dash is B. Now let us check for AB minus BA. We will calculate the dash of this. We know that A minus B the whole dash is A dash minus B dash. Using this property, we can write it as AB the whole dash minus BA the whole dash. And we know that AB the whole dash is B dash A dash, reversal law for transpose. So using this law, we get B dash A dash minus A dash B dash. And we know that B dash is B and A dash is A. Let us take minus sign common. We get minus of AB minus BA. So we have proved that dash of AB minus BA is minus of AB minus BA. Therefore, AB minus BA is skew symmetric. Option A is the correct answer. Next question 21. A matrix is cos alpha minus sin alpha, cos alpha, and A plus A dash is I. Then the value of alpha is. A matrix is cos alpha minus sin alpha, and cos alpha. Plus, let us write A dash. We will change the rows into columns. Cos alpha minus sin alpha. This is the first column. Now the second row should be written as the second column. Sin alpha, cos alpha. Let us add these two matrices. Add the corresponding elements. We get 2 cos alpha, 0, 0, 2 cos alpha. And it is given in the question that this is equal to an identity matrix I, that is 1, 0, 0, 1. It must be of order 2 by 2 because A and A dash are of order 2 by 2. Let us equate the corresponding elements of these two matrices. We get 2 cos alpha equal to 1. Therefore, cos alpha is half. Therefore, alpha is pi by 3 from the principal value branch. The correct option is B. Question 22. Matrices A and B will be inverse of each other only if AB equal to BA equal to I. If this condition is satisfied, A inverse is B, B inverse is A. D is the correct option. Question 23. If A is alpha, beta, gamma minus alpha is such that A square is I, then let us first find A square. A square is A times A. Don't square each and every element of A. Let us write A matrix. This is also A. Both are of order 2 by 2. Product is also of order 2 by 2. Let us multiply first row with the first column. Alpha square plus beta gamma. First row into second column. Alpha beta minus beta alpha. Second row into first column. Gamma alpha minus alpha gamma. Second row into second column. Gamma beta plus alpha square. This is equal to alpha square plus beta gamma, 0, 0, alpha square plus beta gamma. And the question says that it is equal to an identity matrix. We have to take of same order 2 by 2. Now let us equate the corresponding elements. We get alpha square plus beta gamma is equal to 1. Let us take these two elements to the other side. 1 minus alpha square minus beta gamma is 0. This is the condition. C is the correct option. Question 24. If the matrix A is both symmetric and skew symmetric, then we know the definition of a symmetric matrix. A dash is A. And for skew symmetric, A dash is minus A. Now let us substitute for A dash from the first equation. A dash is A is equal to minus A. Now bring this minus A to this side. A plus A is 2A is equal to a zero matrix. Therefore, A is a zero matrix. Option B is the correct answer. Question 25. If A is a square matrix such that A square is A, then I plus A the whole cube minus 7A is equal to. In case of matrices, we cannot use the identity A plus B the whole square or A plus B the whole cube. These identities cannot be used in matrices because A plus B the whole square is A plus B times A plus B. If we use the distributive property, it is A square plus AB plus BA plus B square. And we know that matrix multiplication is not commutative. So we cannot write this term as 2AB or 2BA because AB may not be equal to BA. Therefore, we cannot use these identities for matrices. But if one of them is an identity matrix I, then we can use the identity. We can use I plus A the whole square identity or I plus A the whole cube identity because AI equal to IA equal to A. Now let us use this here. I plus A the whole cube minus 7A is equal to, I'm expanding this, it is I cube plus 3I square A plus 3IA square plus A cube minus 7A. I cube is I. 3 times I square is I times A is A. 3 times I into A square is A square, but A square is given as A in the question. Plus, now A cube can be written as A square times A or A times A square. Both will give you the same answer. And A square is A. Again we get A square, which is A. Therefore, A cube becomes A minus 7A. 3 plus 3 plus 1. We get plus 7A minus 7A. They are getting cancelled. The answer is I. The correct option is C. Now let's do the MCQs of determinants lesson. Question 26. If two determinants are equal here, then x is equal to. If two determinants are equal, their values should be equated. We don't equate the corresponding elements because a 2 by 2 determinant can be equal to a 3 by 3 determinant. That means their determinant values are equal, not the corresponding entries. Whereas in matrices, we cannot equate two matrices of different orders. Okay, let us calculate the determinant value of the first one. X square minus 18 times 2 is 36. And determinant value of the second one is 36 minus 36, which is 0. We get x square equal to 36. Therefore, x is plus or minus 6. B is the correct option. Question 27. Let A be a square matrix of order 3 by 3. Then determinant of Ka is equal to, we have a formula for this. It becomes K raised to n times determinant of A. Because in a determinant, we can take out the common factors from each row or from each column. And here it is a 3 by 3 determinant. From each row, we can take out the constant K. So it becomes K into K into K, which is K cube. The order is 3 here, n is 3. So K cube times determinant value of A. C is the correct option. Question 28. Which of the following is correct? Determinant is a square matrix. Determinant is not a matrix. This is wrong. Determinant is a number associated to a matrix. No, we can find the determinant value only for a square matrix. For rectangular matrices, we cannot write a determinant. C option. Determinant is a number associated to a square matrix. Yes, this is correct. None of these. Okay, C is the correct option. Question 29. If area of triangle is 35 square units with vertices 2 minus 6, phi 4 and k 4, then k is. The area of the triangle formula is half into x1, y1, 1, x2, y2, 1, x3, y3, 1. And this area formula has an absolute value sign. If we write the absolute value sign, it is 35. Now to remove the absolute value sign, I have to write plus or minus. So whenever area is given in these questions, write plus or minus 35 because this formula doesn't have absolute value sign. Now we will take 2 to the other side. 35 times 2 becomes 70. Let us expand this determinant along the first row. 2 times 4 minus 4, minus of minus 6 plus 6 times 5 minus k plus 1 into 20 minus 4k. This is 0. 30 minus 6k plus 20 minus 4k is plus or minus 70. Let us add the like terms. 50 minus 10k is plus or minus 70. We can cancel 10 throughout. We have two equations to solve. 5 minus k equal to plus 7 is one equation. 5 minus k equal to minus 7 is the other equation. Let us find k. K is 5 minus 7, which is minus 2. Here k is 5 plus 7, which is 12. We have two answers for k. If we forget to write plus or minus sign, we will get only one answer. D is the correct option. Question 30. If determinant, a 3 by 3 determinant is given, capital Aij is cofactors of small aij, then value of the determinant is given by. We know that a determinant can be expanded along any row or any column. If elements of a row or column are multiplied with their corresponding cofactors and added, we get the determinant value. If I take the elements of the first row, I have to multiply them with their corresponding cofactors and add to get the determinant value. See the suffixes, they are same. So in these options, only here the suffixes are same, 1, 1, 2, 1, 3, 1. Therefore, this gives the determinant value. Whereas, if elements of a row or column are multiplied with cofactors of any other row or column, then their sum is 0. For example, if I multiply the first row elements with the second row cofactors, that is A21, A22, A23, and add, the answer will be 0. Here we get the determinant value only in the case D. D is the correct option. Question 31. Let A be a non-singular square matrix of order 3 by 3. Then determinant of adjoint of A is equal to, we know this formula, determinant of A whole power n minus 1. Here n is 3, so 3 minus 1 is 2. B is the correct option. This is an important formula. Question 32. If A is an invertible matrix of order 2, then determinant of A inverse is equal to. Invertible matrix means inverse exists and it is of order 2. Then determinant of A inverse can be written as determinant of A whole power minus 1, which is 1 by determinant of A. Determinant of A can be written as determinant of A. Both are same things. So B is the correct option. This is an important question. Question 33. If x, y, z are non-zero real numbers, then the inverse of matrix A is. Look at this matrix. This is a diagonal matrix. What is a diagonal matrix? Non-diagonal elements will be zeros. So for a diagonal matrix, it is easy to write the inverse. Just you have to write the reciprocals of the diagonal elements. Non-diagonal elements will be zeros. Okay, you have to remember this. Similarly, for a diagonal matrix, writing a power n is also easy. You have to Write x power n, y power n, z power n as the diagonal elements, and non-diagonal elements will be zeros. So remember these 2 points. You can save time in the examination. This is applicable only for diagonal matrices. Now we have to find the inverse in this question. So the correct option is A. Or if you don't remember, you can find by the adjoint method. To use the adjoint method, we have to first find the determinant value of A. So expanding along the first row, we get x times yz. The other two terms are 0. The determinant value is xyz. A inverse is 1 by determinant of A times adjoint of A. Determinant value is xyz. Let us write the adjoint. Cofactor of the element x is yz, and cofactor of 0 is 0. Cofactor of this element is 0, and for this element again 0, and for this y it will be xz, 0, 0, 0, and for z it is xy. Let us write the transpose of this matrix. It is the same because it is a diagonal matrix. So let us multiply with 1 upon xyz. We get 1 by x, 0, 0, 0, 1 by y, 0, 0, 0, 1 by z. So if you remember that for a diagonal matrix, the inverse is reciprocal of the diagonal elements, easily we can answer this question. Question 34, this is the last question of determinants. Let A be a 3 by 3 matrix is given where 0 less than or equal to theta less than or equal to 2 pi. Then let us expand this determinant along the first row. 1 into 1 minus of minus, so plus sine square theta. Middle term gets a negative sign. Minus sine theta times minus sine theta minus of minus plus sine theta. And the third term, 1 into minus plus sine square theta minus of minus is plus. This second term becomes 0. We have 1 plus sine square theta plus 1 plus sine square theta, which is 2 times 1 plus sine square theta. We know that minus 1 less than or equal to sine theta less than or equal to 1. The range of sine function is closed interval minus 1 to 1. Now when we square it, it becomes 0 less than or equal to sine square theta less than or equal to 1. Because when we square, all these real values will become positive. Therefore, the range for sine square theta is closed interval 0 to 1. Let us add 1 throughout. 0 plus 1, 1 plus sine square theta, 1 plus 1 is 2. Now to get this 2, we will multiply throughout by 2. 2 less than or equal to 2 times 1 plus sine square theta less than or equal to 2 2s are 4. Now this is our determinant value A. Therefore, it is a closed interval 2 to 4. D is the correct option.